Hello everybody, and welcome to the last lecture in Module 1. We're going to be talking today about pseudoscience versus science, what is real and what is fake. There's lots of fake out there, so hopefully you can learn to identify it so you will not fall prey to it. When we're evaluating information anywhere in our world, on TV, the internet, even in journal articles or magazines, do not confuse science with pseudoscience. Pseudoscience really tries to fool you. Pseudoscience is literally false science. That's the definition of it. Trying to convince you or selling you something is one of the biggest businesses of pseudoscience. They want to try to get you to come over to their side or to agree with their opinion or whatever it is. They're trying to show you, oh, we have evidence to support this, when necessarily they don't have evidence to support that. So a lot of times the source will seem very science-y. It will have people in lab coats, it will have books on the wall, it will use lots of jargon so it sounds all scientific and whatnot, but it doesn't have the evidence behind it that science demands. So it's really not science. So it can be tricky to decipher between the two. I'm going to use graphology, or the study of handwriting, as a way to understand personality or predict personality, as an example of pseudoscience. Excuse me. To hopefully help you understand pseudoscience. So, first of all, graphology, like all pseudosciences, associates itself with real science. So pseudoscience itself as a whole associates itself with real science. It tries to jump on the bandwagon with whatever science is out there that you might know about, that might be popular out there. So for example, right now, forensic science is real popular. So when we hear people using handwriting experts in forensics, that sounds like, ooh, maybe that's real science. So graphology might be legitimate science because they're using handwriting experts. Well, usually forensic science is using handwriting to identify individuals, not to predict their personalities. That might be something you see on TV, but that's not real science. So they try to make it look scientific, but they're not using it for the same purposes or in the same way. So that's an example. Associating itself with a science that you might know, trying to look all sciencey. Secondly, pseudoscience relies on anecdotal evidence. Stories, personal stories, evidence that's not gotten by the real scientific method. So, for example, in this case with graphology, maybe Lady Gaga's attention-seeking behavior, the way she is, might actually be predictable from her handwriting. Maybe she has really big loopy handwriting and very magnanimous expressiveness in everything she does. That might be used as an example of how graphology is a way that we can definitively predict someone's personality from their handwriting, even though that is an extreme example that is not necessarily a good example. Okay, so first, it associates itself with real science. Secondly, it relies on anecdotal evidence. Third, and really most importantly, it sidesteps disproof. Remember, at one point or a couple points we talked about how important disproving things, or being able to disprove theories and hypotheses and whatnot, is to science. Pseudoscience tends to sidestep that and explain away situations that do not conform to its expectations. So, for example, if someone does not cross a T like an extrovert is supposed to cross a T, they might say, oh, well, still, this is still an extrovert because look at the size of the T, or look at how boldly they did the strokes. So if it doesn't conform with their idea, they can sort of dismiss that and say, yeah, but these other things explain it, so it still works. That kind of sounds like Freud in his theory of the id, ego, superego, where you can say, no, I am not in love with my mother, and he says, you're in denial, and you say, okay, yes, I am in love with my mother, and he goes, I was right. So either way, you can't win. It's not testable, really. And that is another important aspect of pseudoscience. So another thing, and the fourth main thing that we're going to talk about here, is that it takes complex topics or phenomena, like personality, which is hugely complicated, and tries to explain it using simple rules, things that people like to catch on to and go, ooh, I like the idea that extroverts use big letters, and people who are attention-seeking use loopy letters, and introverts use small letters, or neat people use, or I guess I should say conscientious people use very neat handwriting. That's simple and it's appealing, but there's no evidence to support it. In fact, scientific research into handwriting predicting personality there's no evidence to support it, basically. There's chance findings, 50-50. So that's not good enough for science. So take a second and think about an example for yourself of something that you might think of as a pseudoscience. Just think about it for a second. What's something out there that people might claim is science, but it really isn't? Just think about that for a second, write it down, bring it to class, and then we'll talk about it and we'll put it to the test and see if it really is a pseudoscience. Okay, now the next thing I want to talk about is the way that you can kind of put your pseudoscience to the test. Is it pseudoscience or science? Well, one way you can tell is to ask yourself whether, first, the general approach to the topic is intuitive, that is, it's sort of emotional, or if it's empirical, that is based on direct experience. Okay, so that's one thing to ask yourself. Secondly, you need to ask yourself whether the observation is casual and uncontrolled, or whether it's systematic and controlled, the way that science likes to be. Third, ask yourself whether the attitude towards the whole topic is accepting and open and kind of uncritical, and oh yes, 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 all these things count, or if it's critical and skeptical and asks questions and says, yes, but what about that uncrossed T, or that T that wasn't crossed properly? We have to explain that. Reporting, ask yourself whether it's biased and subjective, coming from your own perspective, or objective, meaning that the conclusions that you form are separate from your own predictions, because you basically need to say, this is what I think is true, but then if your data doesn't support that, you can't explain it away. You have to still say, oh well, the data didn't show it, so I guess I'm wrong. Another thing to do is to check and see if the concepts are ambiguous or clearly defined. So a concept that's ambiguous might be something like personality, very broadly defined, not clearly defined. And handwriting, very amorphous. Well, what do you mean specifically by handwriting? How have you defined it exactly? How have you almost quantified it? Right, so science would expect it to be clearly defined and translated into something that we can actually numerically count. Ask yourself if your instruments that you're using are precise or imprecise. Are they using tried and true instruments, or are they just kind of coming up with their own stuff and throwing it out there? If they're using their own materials and they haven't been shown to be valid, that means true, or reliable, that means you can get the same findings over and over again, then we have to question whether what they find is even valid, because if they're using bad instruments, it's like using a bad scale and then trying to sell someone something based on how much it weighs. It might not be fair. Another thing to ask yourself, are the measurements invalid or valid? So instruments are the things, the tools that we're using, and measurements are sometimes parts of the instruments, but if they are valid, that means that they are shown to be scientifically accurate through a long, laborious process of doing that. And again, reliable means that they are I don't want you to think that it's replication. It means that you get the same thing every time. So against the scale example, every time you get on the scale, it gives you the same measurement. Finally, ask yourself whether the hypotheses are testable or untestable. Pseudoscience has untestable hypotheses often because they have such general concepts, and their instruments are not necessarily precise, and their measurements are not necessarily valid. And so when they haven't precisely defined things, it's hard to test those hypotheses because you're not sure exactly what counts as true or false. So these are the things that we ask ourselves when we're trying to decide if something is real science or not. Now, if you're trying to decide whether to go to the chiropractor, and you want to know if it's a pseudoscience, it's a lot of work to go through and ask yourself all these questions. And I know that you're not going to do it every time, but just try to get into the habit of thinking about some of these issues as people confront you with questions or things that you're thinking about spending money on. Should I buy this equipment that's supposed to help me lose weight, or whatever it is that I'm interested in? Think about these and see if the science behind it is real science or if it's pseudoscience. It's often hard to tell, but you can get good at it if you practice. Alright guys, I'll see you in the next module.